Every high-speed train begins with carefully selected raw materials. Inside this massive factory, metal will soon.
The manufacturing process begins as massive deliveries of aluminum, steel, and precision materials arrive at the train production facility.
Before production begins, every material is carefully inspected to ensure it meets the strict standards required for high-speed train manufacturing. The approved aluminum sheets now enter the production line. They will be transformed into the lightweight body panels of the high-speed train. Advanced laser systems cut each aluminum panel with extreme precision, creating the exact shapes required for the train's aerodynamic body. The flat panels are now precisely formed into aerodynamic curves, helping the train move efficiently through the air at high speed.
At the front of the train, precisely shaped panels begin forming its aerodynamic nose, designed to reduce air resistance at high speed.
Inside the factory, strong, lightweight carriage frames are assembled to create the structural foundation of the high-speed passenger train. Now, robotic welding systems join the train's structural components with thousands of precise welds, creating a strong and lightweight body. The lightweight train body is now complete. Next, engineers will transform this empty shell into a powerful high-speed. With the outer body complete, reinforced structural components are installed to give the high-speed train the strength needed for years of demanding service. Beneath the passenger cabin, a reinforced underbody structure is prepared to support the train's heavy mechanical and electrical systems. The train's running gear begins with a precision-built bogie frame. It is designed to carry the carriage and guide it smoothly at high speed. Precision machined wheels are mounted onto the axles, creating the foundation that will carry the train safely along the track. Advanced suspension systems are installed to absorb vibration and help passengers enjoy a smooth ride at high speed. Powerful electric traction motors are installed beneath the train, providing the force needed to accelerate this high-speed passenger train.
A high-speed train needs powerful and precise braking systems, so every braking component is carefully installed and tested.
Beneath the carriage, complex electrical and cooling equipment is installed to manage the enormous power required for high-speed operation. A streamlined pantograph and high-voltage roof equipment are installed to connect the electric train to its external power supply. Specialized coupling systems are installed, so multiple identical carriages can operate together as one complete high-speed train. The individual carriages are now connected, transforming separate sections into one long, powerful, high-speed electric passenger train. The train now has its complete mechanical foundation. Next, its electrical systems, interior, and signature exterior finish.
Before paint can be applied, the entire train body is carefully cleaned and prepared to create a perfectly smooth surface.
A protective anti-corrosion treatment is applied to help shield the train's metal body from moisture and harsh environmental conditions.
The painting process begins with a smooth primer layer. It prepares the train body for its final aerodynamic finish.
Now the train receives its signature white and metallic silver exterior, giving the high-speed machine its sleek.
A continuous blue accent stripe is carefully applied along the train, completing its distinctive aerodynamic design. A protective clear coat is applied and cured, giving the train a durable, glossy finish designed to withstand years of high-speed operation.
Inside the train, thousands of cables and electrical connections are carefully installed to control everything from propulsion to passenger systems.
The empty carriage now becomes a passenger cabin, as rows of comfortable seats are installed inside the high-speed train.
Interior panels, flooring, lighting, and passenger systems are added, transforming the metal carriage into a modern travel environment.
Large panoramic windows and precision automatic doors are installed and sealed, completing the train's streamlined passenger exterior. At the front of the train, a sophisticated control cabin is installed to monitor and manage every part of the high-speed journey.
The transformation is nearly complete. With its systems and interior installed, this high-speed electric train is ready for final testing.
After months of manufacturing and assembly, the final exterior components are carefully installed before the train begins its testing journey.
Before the first test run, engineers carefully inspect the roof-mounted power systems that will supply electricity to the train.
Every electrical system is tested, from propulsion controls to passenger lighting, communication systems, and onboard technology.
Before high-speed testing begins, every braking and safety system must perform perfectly under controlled conditions.
Even the smallest details are tested, from automatic doors and passenger displays to lighting and emergency systems.
After passing its stationary tests, the train finally begins to move as engineers prepare for its first dynamic track.
Now the train faces its ultimate test, accelerating along the track to prove its performance, stability, and high-speed capability.
After completing its performance tests, the train returns for one final inspection before being approved for service.
From raw metal to a fully tested high-speed machine, the train is now ready to begin its journey beyond the factory.
From raw materials and precision engineering to a fully tested high-speed train, this is how modern transportation comes to life.